So in the last part we left off having created a really simple UDP server, and in this part we're going to start building the request that we're going to send back to answer every DNS query. So we need to go into our text editor, and instead of just printing the data out, we want to send data back. So Python has a really simple function designed just for this, and the way we use it is we say sock.send to, and we pass it two parameters. The first one is the data we want to send back, and the second one is the address. So the first one we're going to say hello world, and the address is just going to be ADDR because we want to send data back to the address of the computer that sent us the request. And send to doesn't take regular strings, it takes a string of bytes, so we need to put a B in front of that. So let's just run this. So we're going to hit enter there, we're going to run the server, and now we're going to send a request using dig. So we're just going to run that, and you can see we got an error in dig. Dig returned an error because the response we sent back isn't what it expected, because we didn't actually send a real DNS response back, we just sent back the data that dig sent to us. And this is our server, so just close that as well, and we're going to go to Wireshark and see the data that we sent back. So here is our Wireshark. I'm just going to filter it to the DNS server, and this is the request we sent from dig. This is the request we sent back, and as you can see it says malformed packet, because what we sent back wasn't a valid DNS response. But if we look down here, you can see it says hello world. That is the exact data that we sent back. So now that we're able to send data back from the server to the client, we need to start building the DNS response that we're going to send back. So instead of sending back hello world, we want to send back our DNS response. So I'm just going to create a variable called R, and we're going to send R back to the client, and R is going to be our DNS response. R is going to be equal to the output of our build response function. And build response is going to take data as a parameter, because in your DNS response you have to retrieve some of the information from the request, such as the transaction ID and things like that. So we need to pass data to our build response function, so build response can read the original request and extract information like the transaction ID and things like that. So we're going to go up here, we're going to create our method, we're going to say def build response, pass it data. And if we go back to Wireshark, we can see here that in our original request, so the start of our DNS query is the transaction ID. And we can check that if we just click here, you can see this whole blue section down here is the DNS query. And if we click on the transaction ID, the first 2 bytes are the transaction ID. So now that we know that, we can go back to our build response method, and we can say transaction ID is equal to data. And this data variable is a string of bytes. So we can access a subset of that string of bytes using the normal ways you'd expect in Python. In this case, to get the first 2 bytes, we can say 0 to 2, which means get the byte at the 0th index and the byte at the first index. We can also make it even shorter, and we can just get rid of the 0 and say :2 to get the first 2 bytes. What that'll have done is it will have gotten these first 2 bytes, B569. And those are the first 2 bytes of the DNS header, and those are the 2 bytes that we need to get from the actual query, because we need to send them back in the response. So now I'm just going to try and print out the transaction ID. So the way we do that is just say print transaction ID, run the DNS server again, and send the request again. Close that because obviously there's not going to be a response, so dig will just keep trying to send DNS requests. And we got an error because essentially what happened was we tried to assign the return value of build response to the variable R. So essentially what that did was give R the value of none, and then essentially we're trying to send none over the send to method, and that method expects a string of bytes. But you can see if we go above the error, it says we got a string that says 03, and that means we have 2 bytes, but the terminal has tried to convert those 2 bytes into actual characters. It's tried to convert them to ASCII characters, and that's why we got 03. They're actually 2 individual bytes. We can actually see the individual bytes themselves if we say for byte in transaction ID, print byte. Run this again, and you see we got the integer values of the 2 bytes. If I convert these bytes into hexadecimal numbers, run it one more time, you can see we got the hexadecimal number EE, and then we got 63. If I go back to Wireshark, you can see here the transaction header that was sent, the most recent one is EE63. So essentially what we've done is grab the first 2 bytes out of the request, and we have got them now, and we can use them in our response. So what we need to do is we need to create a variable called TID, which is short for transaction ID, and that's just a regular string. And in here, what we want to do is we want to say TID plus equals, and we want to append the byte on. You can see if we print this now, you can see we get OX3B, and 3B is the first byte, and OX82, and 82 is the second byte. We need to remove the OX at the start. First, we're going to remove the surrounding parentheses, and then we're just going to simply say start on the second index and go until the end of the string. So we're just essentially getting rid of the first two characters. We run this one more time, and we have our bytes. We have 49, and then we have 11, and they're two separate bytes. And that is a transaction ID. If we go back to Wireshark, you can see the next part of the query is the flags. Here are the flags here, and we need to set these in our response. So to do that, what we're going to do is we're going to just, instead of printing TID, we're going to go down here after we have the transaction ID. I'll just create a comment, we have the transaction ID. Down here, we want to get the flags, and here we'll say flags is equal to get flags, and we'll say data, and we will pass it data, and we will start on the second index and go to the fourth index. The reason for that is because if we go back to Wireshark, we can see that when we click on flags, there are 2 bytes highlighted, and those are bytes 3 and 4. And those will be indexed as bytes 2 and 3 because strings and arrays and everything like that in Python starts from 0. So essentially what we're doing is we're passing the third and the fourth byte to the getFlags method. So that's it for this video. Don't forget to like, comment, favorite, and subscribe, and I'll see you next time.